Okay, question 2, part A. On an Argand diagram, shade the region whose points represent a complex number z satisfying the inequalities. This is our first inequality and this is our second inequality. Okay, so for those of you who do not know what an Argand diagram is, basically an Argand diagram is a diagram on which we plot complex numbers, imaginary numbers. So what we do is we have our origin and it looks sort of like this. The x-axis is the real part of z, the point we're plotting, and the y-axis is the imaginary part of z. So the real part of z is whatever part of z that does not have the I, and the imaginary part is the part that has to do with the I. So suppose over here we have this -1, -2i. -1 is the real part and -2i is the imaginary part. So then we get to plotting it. So first what we'll do is we'll plot the easier inequality to plot, which is real of z is less than equal to 3. So for that what we have to do is we already know that the real is on the x-axis. So we have to plot all points that are less than equal to 3. So for that we'll draw a straight line on the 3, and whichever points are less than equal to 3, they will be on the left hand side of this line. So when we're drawing, we have to be sure that we shade the left hand side of this line. Then the second inequality we have to plot is the arg. So over here this has to do with an angle, and this is a little harder to plot, but first what we have to do is we have to turn this z -1 -2i into a form that we can actually use. So for that we make it into 0.1 minus 0.2 form, so z minus 1 plus 2i. So we take the minus common and we make it 1 plus 2i. So what's cool about the 0.1 minus 0.2 form is from here you can directly plot it onto the graph. So 1 is our real number and 2i is our imaginary number. So 1 on the x-axis, 2 on the y-axis. So this is our point. Now what you want to do is you want to draw an imaginary line that is 0 degrees to this point. Okay, you can draw that using a scale, a protractor, whatever you have. Just draw a line for reference. From there what you need to do is you have to draw two lines. So first line would be the minus 60 degrees, which should be something like this. And the second line would be the plus 60 degrees, which would be like this. Now over here, you can use a protractor to draw it, which is the ideal case. So 60 and minus 60. Then after that, we shade the region. So it is to the left of this line. And since it's less, the argument is less than 60 degrees but greater than minus 60, so it's whatever is between here. Okay, you have to be careful when shading so you don't shade the wrong region, but over here it's the line between. Now what to do if we do not have a protractor present with us? So ideally you should be bringing a protractor to your exam, but if you do not, then no problem, we're going to be using trigonometry to solve this. So suppose we consider this triangle right here. We are considering this as a triangle. So that's this triangle. Now we know over here that there's this imaginary line and there is a 60 degrees over here. And since this is a 90 degree, then this is a 30 degree. So we have a triangle. We know this angle is 30 degrees. The height of the triangle, since we had 1 plus 2i and our y-axis is the imaginary, so the height is 2 units. This is 2 units. Now we need to find out the area underneath, the x coordinate. So let us write that as x. We use trigonometry to find x. So tan 30 is equal to x upon 2. X is equal to 2 tan 30. So this total area, so since this is x, we need to incorporate this area as well, which is a 1, since it's 1 plus 2i. So the total x coordinate will be 1 plus 2 tan 30. Now you just plot that point over here, which should ideally be around 2.15. You plot it over here, and the line that you draw goes through 1 plus 2i and through your 1 plus 2 tan 30. So you just plot that on this side, take the opposite for the positive side, and then you just shade the region in between. Okay, for part B, we have to calculate the least value of arg z. So least value of arg z for points in the region from A. We have to give our answer in radians and we have to give it correct to 3 decimal places. So this is our part A, and the shaded region is the values that satisfy part A. So our least value of arg z would be from the origin the lowest point that satisfies the graph. So approximately this point. Now over here what we have to do is let us draw it as a triangle. So this is a triangle. This triangle corresponds to this triangle. So we need to find this value. Let's take it as y, and we need to use the sides over here and these two sides and the trigonometric ratios to find arc z. So let's see how we're going to do it. So first we'll draw the triangle over here, and we need to find this y. Now let's see what we already know. So first thing we have to know is we have to know the x coordinate, the real value. So since this line, it lies on 3, so we know that the x coordinate of the triangle is automatically 3. So let's just get that out of the way. Now the second thing we have to find is we have to find the y coordinate of the line, this area right here. So for that what we'll do is we'll go back to our first triangle. So let's take this as triangle number 2, this one right here, the one marked in yellow. So for the one marked in yellow, we know that the angle it makes is 60 degrees. Okay, since the line is at 3 and this is 1 plus 2i, so the real value over here is 1. So 3 minus 1, 2, so this is the coordinate over here, 2. Now you need to find the height of this triangle. So let's take the height as x using the tan ratio. We're going to be finding that tan 60 is equal to x by 2. So x is equal to 2 tan 60. Tan 60 is equal to root 3. So 2 root 3. So we know now that this entire area is 2 root 3. And we know that this area over here is equal to 2. Since it's 1 plus 2i, so this is 2i. But we take out the I when doing the calculations. So it's 2 root 3. This area is 2. So the area left, this blue area right here, this is 2 root 3 minus 2. So let's just input that into our triangle over here. 2 root 3 minus 2. Now what we'll do is we'll use the tan formula again. So tan y is equal to 2 root 3 minus 2 upon 3. So y is equal to tan inverse of 2 root 3 minus 2 by 3. Now what we have to keep in mind is since y is in the fourth quadrant, it's not exactly y, it's minus y, since whichever angle is in the fourth quadrant would be in negative. So minus y and tan minus y over here. So y is equal to negative of tan inverse 2 root 3 minus 2 by 3. Now if we sort that out and we calculate it in radians, correct to 3 decimal places, our answer is coming as minus 0.454 radians correct to 3 significant places, sorry, 3 decimal places. So this is our final answer.